Just how powerful is nuclear energy? Uranium pellets like this one fuel all nuclear energy in Canada. Just 8 of these is enough to power your house for an entire year. It's about the same amount of energy as 400 kilograms of coal, or about 0.5 cubic meters of coal pieces. 410 liters of oil, which would fill about 2.5 of these small pools. Or about 350 cubic meters of natural gas, which would fill about 8 of these train cars. So how do all of these give us power? The main idea behind most power plants is to produce heat. This heat is used to boil water, produce steam, turn a turbine, and power an electrical generator. The only difference is how the heat itself is produced. Fossil fuel stations use coal, oil, or natural gas to produce heat, while nuclear stations use the heat from nuclear reactions. Energy from nuclear reactions comes from an atom's nucleus when it splits. The job of a nuclear reactor is to capture this energy. In a nuclear reactor, the radioactive element of uranium is compacted into fuel pellets and then placed into fuel bundles.
So this is a fuel bundle. This is what gets put into the core of the reactor to produce the nuclear reaction. It includes uranium pellets that are stacked into these tubes here.
As the uranium releases energy through nuclear reactions, water that flows around the fuel bundles is heated. This water surrounding the fuel bundle acts as a coolant to remove the heat from the reactor up through the pipes to the steam generator. This steam turns the turbine to generate electricity and heads out through the electricity grid. In Canada, all reactors are CANDO designs, engineered by Atomic Energy of Canada Limited in partnership with Ontario Power Generation, GE Canada, and over 100 other Canadian manufacturing and engineering companies. CANDO is an acronym that stands for Canada Deuterium Uranium Reactors. Its innovative Canadian design makes use of natural uranium and an isotope of hydrogen called deuterium.
So there are a lot of CANDO reactors in Ontario. It's a big part of the energy portfolio of the province. There's one reactor in New Brunswick and there was one in Quebec. On an international level, you can find CANDO reactors in Romania, South Korea, China, Argentina, and also there are CANDO-like reactors in India and Pakistan.
An important feature of the CANDO reactor design is the use of deuterium oxide, also called heavy water. A water molecule is made up of 2 hydrogen atoms and 1 oxygen atom. In heavy water, the hydrogen atoms have been enriched with an extra neutron to create what is called deuterium. The heavy water is called a moderator because it surrounds the fuel bundles and moderates the neutron flow inside the reactions. When all the parts of this nuclear reactor come together, a thick layer of concrete shielding helps contain the energy.
So you see how small this fuel bundle is. This is enough to produce sufficient energy to supply a house for a family of 4, all the electricity that we need for 100 years.
Nuclear energy is based on harnessing the energy released when the atomic nucleus is split. The anatomy of the atom consists of a cloud of electrons in orbitals surrounding the nucleus at the center. Chemical reactions involve the arrangement of these electrons. The atomic nucleus at the core of the atom consists of protons and neutrons. 2 forces are at work here. The nuclear force is attractive between neighboring protons and neutrons alike. However, electrostatic force is repulsive. Each proton repels and is repelled by all other protons in the nucleus. The balance of forces within the nucleus is a push-pull between nuclear force, which stabilizes the nucleus, and electrostatic force, which destabilizes the nucleus. Neutrons contribute to stability without destabilizing electrostatic repulsion. Nuclear fission is created when a heavy nucleus teetering on the edge of stability, like uranium, can be pushed over the edge by adding 1 more neutron. If the nucleus splits in 2, a process called fission, a large amount of energy is released as the 2 positively charged daughter nuclei fly apart when liberated from the binding nuclear force. In addition to the daughter nuclei, fission releases more neutrons, which can then go on to promote more fissions, thus starting a chain reaction. The energy released in nuclear fission is 100,000 times more than the most powerful chemical reaction. Fossil fuels, when used to generate energy, create enormous quantities of CO2 that will stay in the atmosphere forever. Fossil fuel has a large effect on global climate. Nuclear energy, when used to generate power, has occasional bad accidents and creates small amounts of nuclear waste. Nuclear weapons proliferation is also a concern. In comparison to fossil fuel, nuclear energy has a small effect on our global climate.